Scene script. Have you ever pondered the nature of time and space? Could time move both forwards and backwards in tiny intervals? Let's delve into a fascinating realm where the lines between matter and antimatter blur, where mirror images become reality. Now imagine this. Matter and antimatter, they're identical save for the fact that they're mirror images of each other. Just like your reflection in a mirror, electrons and positrons, among other particles, exist in opposition as matter and antimatter. But what if I told you that empty space-time could act in a similar way? Just like a mirror in the void, it could cause matter to behave like its mirror image, antimatter. Picture this, the same matter, but in the opposing space-time field, behaving as antimatter. Intriguing, isn't it? As we perceive time moving forward, we see a Mobius-like shape progressing, and to return to its original state, it needs to complete a full 720-degree rotation. These rapid back-and-forth flips, like a pendulum swinging, slice all matter within our universe into quanta or packets, revealing both packet and wave characteristics. But here's the twist. In the backward arrow of time, everything reverses. What was matter now appears as antimatter. It's as if we're looking at the universe through a mirror, everything flipped and mirrored. Space-time, it appears, is not a one-way street. It doesn't just advance in one direction. Its fields shift back and forth as frequently as Planck time. But time remains constant, only swapping directions rapidly between positive and negative, past and future. This means time goes backward and forward, while matter within this space-time also mirrors itself. So consider this, our perception of time progressing, of the future unfolding before us, it's actually a result of these rapid flips between matter and antimatter states, a dance of cosmic proportions, where each step forward is mirrored with a step back. Yet we move forward, drawn towards the future. And that, my friends, is the nature of time and space. Imagine time as a Mobius strip, moving forward, yet requiring a complete 720-degree rotation to return to its original state. This is a concept that can seem baffling at first, but it's a key to understanding the nature of time and how it shapes our universe. Now let's delve into the concept of quanta, or packets. These tiny, discrete units of energy exhibit wave characteristics, showing us that energy, much like time, has a dual nature. It exists both as matter and as a wave. And this duality is one of the fundamental principles of quantum physics. Our universe, then, isn't a continuous expanse of matter and energy, but rather a vast sea of these packets, each one distinct and separate, yet part of the whole. But here's the twist. Time doesn't just move forward in a straight line. It's not like a river flowing from its source to the sea. Instead, it oscillates. It swings back and forth, flipping rapidly between past and future like a pendulum in a cosmic clock. This rapid flipping occurs in intervals as brief as Planck time, the smallest measure of time that has any meaning in physics, and as time flips, so does space. The universe turns inside out and matter becomes antimatter, like a mirror image of itself. This is why we can talk about matter and antimatter as being identical in every way, yet opposite. In this rapid flipping, this oscillation of time, we find the reason for the wave nature of particles. Each flip of time, each swing of the pendulum corresponds to a wave of energy. The faster the flip, the shorter the wave, and vice versa. So you see, time doesn't simply move forward. It oscillates, swinging from past to future and back again. And in this oscillation, in this Mobius-like dance of time, we find the roots of some of the most profound mysteries of our universe. What if there's a parallel anti-universe existing alongside ours, mirroring our every move? Imagine, if you will, a universe identical to ours in every way, but its components are antimatter, existing in negative space-time. It's a mind-boggling concept, but let's delve deeper. Picture space-time as a dual-faceted mirror, reflecting both our universe and a parallel anti-universe. The matter in our universe behaves like antimatter within the anti-universe, essentially creating mirror images of each other. It's a cosmic dance of symmetry, an intricate ballet of matter and antimatter. But why can't we perceive this parallel universe? The answer lies in how we experience time. We exist in a single Planck time, the smallest unit of time that has any meaning. Each moment we live, each breath we take, is experienced in these fleeting Planck time intervals. We perceive the passage of time as a continuous flow, but in reality it's a rapid succession of Planck times. Now here's the kicker. While our universe exists in positive space-time, the anti-universe exists in negative space-time. It's like they're two sides of a coin, forever linked but never touching. Our minds can only process the matter in our positive space-time universe, making us oblivious to the mirror anti-universe. This understanding of a parallel anti-universe in negative space-time provides a fresh lens through which we can view time's nature. Time doesn't just move forward, it flips back and forth like a pendulum between positive and negative. We're just aware of the forward swing because that's when we exist in positive space-time. So, in essence, we're living in a universe that is but one half of a greater whole. Our every action, every thought, mirrored in a parallel anti-universe of antimatter. A universe that exists in the negative space-time, forever parallel to ours, yet forever unseen. While we live in the present, each moment is a fleeting Planck time, sandwiched between the past and future. How do particles manage to exist as both waves and individual packets of energy? This question takes us to the heart of quantum mechanics, a realm where the familiar rules of the physical world are twisted into something altogether more perplexing. The wave-particle duality is a fundamental concept in quantum mechanics, revealing that every particle also has a wave nature. This means particles like electrons and photons behave as both particles and waves. But how does this strange duality arise? It all comes down to the rapid flipping of space-time intervals. You see, in the quantum world, time doesn't flow in one direction as we perceive it. Instead, it flips back and forth at incredibly rapid intervals. Intervals as minuscule as the Planck time, the smallest unit of time that has any physical meaning. The result? A particle doesn't exist in a single state at any given moment. Instead, it exists in all its possible states at once. It's only when we measure it that the particle seems to choose its state. This wave-particle duality is not a mere quirk of observation, but a fundamental aspect of the nature of matter and energy. Now let's delve deeper into the realm of quantum weirdness, quantum entanglement. This is a phenomenon where pairs or groups of particles interact in ways such that the state of each particle cannot be described independently of the other particles, even when the particles are separated by a large distance. When we consider the rapid flipping of space-time intervals, this seemingly inexplicable entanglement begins to make a little more sense. Each pair of entangled particles is created within the opposite space-time field. This means that the particles are not just linked, they are fundamentally inseparable. They are not two particles, but two aspects of the same phenomenon. This concept could potentially unravel the mystery of quantum entanglement and provide new insights into the nature of the universe and our place within it. Every particle carries a mirror image that exists in the opposite space-time field, linked together through the fabric of space-time. Why can't we perceive the passage of time the same way a photon does, and what limits the speed of light? These are thought-provoking questions that we must delve into. You see, a photon doesn't experience time like we do. This peculiar particle of light exists in a realm where time flips back and forth, but from its perspective, time remains constant. This is because photons exist within the Planck time, a theoretical smallest unit of time, and the flipping between time fields happens at this minute scale. When we talk about the speed of light, we often imagine it as a physical speed limit. But what if I told you it's more of a temporal limit? This limit is set by the rate at which time fields flip back and forth. The energy of a photon determines the speed of this flip over. The higher the energy, the quicker the flip and the shorter the wavelength of light. Now let's turn our attention to ourselves. Unlike photons, we perceive the flow of time. But why is that? It's because we exist within positive time frames, and our minds add up all the preceding favourable Planck time intervals. This sum gives us our perception of time moving forward, of time flowing into the future. But remember, every next Planck time occurs in reverse time. This flips the space-time field over, creating an intricate dance between time, space and energy. While we are not aware of these rapid flips because our minds only register the matter and not the antimatter, they are essential in understanding the nature of our universe. So, the next time you look up at the night sky and marvel at the stars, remember that the light reaching your eyes is not just travelling through space. but also through time. And the speed at which it travels is not a mere physical limitation, but a fascinating temporal dance. The limit of light's speed is not a physical barrier, but a temporal one, dictated by the intricate dance between time, space, and energy.